Hello, this is Algebra 2, Lesson 22, and this lesson covers uniform motion problems that involve equal distances and similar triangles and proportions. Alright, so uniform motion problems. Now these can be pretty confusing when you first look at them. The main thing for solving these is to lay out all your variables first. Alright, so this says Roger made the trip on Sunday and Judy made the same trip on Monday. Roger traveled 12 miles per hour. Judy traveled 20 miles per hour, so her time was 2 hours less than Roger's time. How far did they travel? So our base equation for this is going to be distance equals rate times time, right? So let's say that you were going 5 miles per hour, right? And you walked for 2 hours, right? So 5 times 2 would be 10. You went 10 miles. In the first hour, you went 5 miles, and then you went another hour. That would make 10 miles, right? So that's our base equation. Distance equals rate times time. But we have two people's distance, rate, and time that we're talking about here. So we're going to have to use subscripted variables. So we're going to say the distance of Roger. These are our variables we're going to have to find. The rate of Roger and the time of Roger, and then we're also looking for the distance of Judy, the rate of Judy, and the time of Judy. Okay, so there's our subscriptive variables. Alright, so it says that Roger made the trip on Sunday, Judy made the same trip on Monday. So that tells us that our distances, the distance of Roger, is equal to the distance of Judy. Okay, so they both went the same distance. Those two are equal. Roger traveled at 12 miles per hour. So his rate of Roger is 12. Judy traveled at 20 miles per hour, so the rate of Judy is 20. So her time was 2 hours less than Roger's time. So we could say the time of Roger minus 2 equals the time of Judy, right? Let's see, so her time was 2 hours less than Roger's time, right? So Roger took 2 hours longer than her. So if we subtract 2 hours off of Roger, we get the time of Judy. Okay, so if we know the distances are the same, like if we break this down and we say the distance of Roger equals the rate of Roger times the time of Roger, right? And then the distance of Judy equals the rate of Judy times the time of Judy. If we look at this and say the distance of Roger is equal to the distance of Judy, that means that this whole part of the equation and this whole part of the equation are equal. So we could say the rate of Roger times the time of Roger equals the rate of Judy times the time of Judy. Does that make sense? Because we're just using substitution, right? So if we took this equation and we said distance of Judy, right? The distance of Judy is the rate of Judy times the time of Judy. And we just replace that for the distance of Roger, okay? Now we can start filling in some of these numbers that we actually know. So rate of Roger, that's 12. The time of Roger, we don't know that one, so we're going to leave that, equals the rate of Judy, which is 20, times the time of Judy, we do know that, is the time of Roger minus 2. So we'll say time of Roger minus 2. Now our only variable is time of Roger, so we just had to get that down to one variable. All right, to solve this, we're just going to copy this down, and then we're going to rainbow right here. So we get 20 times the time of Roger, and then 20 times 2 would be 40. Okay, now we're going to subtract 20, time of Roger, minus 20, time of Roger, and we'll get 12 minus 20 would be negative 8, times the time of Roger equals negative 40. Now we just have to divide by negative 8. And 8 times 5 is 40, so the time of Roger equals 5. so Roger's time is 5, right? And if the time of Roger minus 2 is the time of Judy, that would be 3. Okay, but our main question is how far did they travel? So we just need to know the distance, right? So the distance for both of them. And that's easy to find now that we know those other things. We just need this distance right here. If distance equals rate times time, the rate of Roger times his time would be 12 times 5, which is 60. And if we did that over here, she was going 20 miles an hour for 3 hours, so that would also be 60. And remember, their distances are the same. So the answer is 60 miles. All right. The key to those is making sure that you have that base equation and then listing all your variables out to the side. All right, let's try another one. Brer Rabbit hopped off toward the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began to chase from the same point. If he caught Brer Rabbit at 2 p.m., how fast did he run? Okay, so we could draw a little diagram to show us. Actually, that's not right. Okay. All right, so here's where they started. Right here. Here's our start. Here's where they got caught. Okay. Briar Wolf, let's see, Briar Rabbit started at 10 a.m. So here's our rabbit, and he started at 10. And then Briar Wolf started at noon, and he caught him at 2. Okay, right? So this would be from 10 to 2. The rabbit, 10, 11, 12, 1, 2, ran for 4 hours. And the wolf started at 12 and got there at 2, so he ran for 2 hours. Okay, so that gives us our time. All right, so we're going to have distance equals rate times time. And we're going to have the distance of the rabbit and the rate of the rabbit and the time of the rabbit. And then we're going to have the distance of the wolf, the rate of the wolf, and the time of the wolf. So we just figured out their time. The rabbit's time was 4 hours, and the wolf's time was 2 hours. All right, and it says that the rabbit was going 10 kilometers per hour, so the rabbit's rate is 10. If he caught, how fast did he run? So what we need to know is the rate of the wolf. Right, so this is the one we're looking for. And we know that they went the same distance, right? So the distance of the rabbit is equal to the distance of the wolf. That means we could say, instead of distance, we could replace that with rate times time. So the rate of the rabbit times the time of the rabbit is going to be equal to the rate of the wolf times the time of the wolf, right? Because our distances are equal, so that means our rate times time is equal. All right, so let's start filling in the variables. The rate of the rabbit is 10. The time of the rabbit is 4. The rate of the wolf, we don't know. The time of the wolf is 2. Okay, 4 times 10 would be 40, equals 2 times the rate of the wolf. Then we're just going to divide by 2, and we get the rate of the wolf equals half of 40 would be 20. That one's actually easier than the last one, I feel like. And that's the answer. And it was KPH. On this one, we didn't even have to find out what the distance was. We just need to find that rate. Okay, this next part is about similar triangles. And we've done ones like this before. We're just going to, instead of using a scale factor, we're going to use proportions for this, right? So we're going to have this triangle first. We'll take that on the top, and this triangle will be the bottom, right? So if we make a proportion, we would say 7 to 9, right? So I'd say 7 to 9 is equal to 5 to x. And we know that these are similar to each other because if this angle is the same as this angle, right, that means that this side is the same as this side. Okay, those are going to be proportional to each other. So we could say 8 to y, 8 to y. And then easily we can solve that by cross multiplying. 9 times 8 is 72. Equals 7y, divide by 7, y equals 72 over 7, and in the book they just left it like that, 72 over 7. I think, let me make sure. Yep. And then the other one would be, see what else is proportional. This angle is equal to this angle, so our opposite side, that means 7, would be proportional to 9, right? So we would say, here's our base, 7 to 9, okay? And then that means that this one is to 5, as this one is to x. So 7 to 9, and our top is 5 to x. 9 times 5 is 45, equals, see, I'm just cross multiplying, and cross multiply there, 7x, divide by 7, divide by 7, x equals 45 over 7. So there's the answer to that. You just make it into proportion. Super easy. Alright, go ahead and pause the video and work the practice problems. There are 2 of them. Okay, so hopefully I'll pause this video and work the practice problems. Now I'll work them for you. Alright, this first one, Elvira made a trip on Tuesday and David made the same trip on, can't even read it. There we go. Alright, Elvira made the trip on Tuesday, David made the same trip on Wednesday. Elvira traveled 14 miles per hour, David traveled 21 miles per hour. His time was 3 hours less than Elvira's time. How far did they travel? Okay, so we're going to have the distance of David. Actually, I'll do Elvira first. Elvira times the rate of Elvira equals the time of Elvira. And the distance of David times the rate time of David. Okay, so if we've got distance equals rate times time, their distances are equal, so we're going to have the distance of Elvira. Nope. We're going to have the rate of Elvira times the time of Elvira equals the rate of David times the time of David. Okay, distances are equal. That means rate times time are equal. All right, let's see what we can fill in here. All right, Elvira traveled 14 miles per hour, so that means her rate is 14. David traveled 21, so David's rate is 21. So his time was 3 hours less than Elvira, so we could say time of Elvira minus 3 equals the time of David. Okay, so what can we fill in? We've got the rate of Elvira is 14. We'll leave time of Elvira because we're going to be able to fill in time of David, right, with this. Equals the rate of David, which is 21, times the time of David, which is time of Elvira minus 3. And there we go. We only have one variable. We're going to rainbow that, so 21 TE, and then 21 times 3, which would be 3 times 2 is 63. Okay, this is 14. Okay, and now we're going to subtract 21 those cancel. That would be 7. Negative 63. We're going to divide by 7. That's negative 7. So we're divided by negative 7. Time of Elvira is 9 times 7 is 63. Okay, that means that the time of Elvira minus 3 is the time of David, so that would be 6. And what we need to know is how far they traveled, so we need to know these distances right here. 9 times 14. 9, 10, 11, 12, 126. Just to double check, I'm going to multiply the other one. They should be the same. So they went 126 miles. Should be the answer. I'm going to double check that real quick in the answer key. Yep, 126 miles. All right, next one. All right, on this one we have 2 triangles. And we know that some of these are similar. I'll use some different colors to help us. So this one with 1 right here would be equivalent to this 9. This one with 1 would be the y. So 9 and the y are similar. This 2 little, those are equal, right? So that means that and that are similar, right? Because they're opposite angles, opposite sides, right? The angle opposite that. And then the last one would be this one without a mark has to be the same as this one without a mark. So that means this side, so x to 7. Okay, so now we can set these up as proportions. We could say we're going to do this side first. This will be our top. This side will be our bottom. Okay, so if our top on the orange is 7, our bottom on the orange is x. And our top for 6 would be, our top for blue would be 6, and our bottom for blue would be 5. And then for purple, we've got 9 on the top and y on the bottom. Okay, so here's the one that has numbers. It's the middle one right there. So we could say 6 over 5 equals 9 over y. Cross multiply, 9 times 5 is 45, equals 6y. Divide by 6. Y equals 45 over 6. We could do that for the other one. 5 over 6 equals 7 over x. 6 times 7 is 42. 5x. X equals 42 over 5. Let me make sure that's how it is in the answer key here. This says 35 over 6 and 15 over 2. I've done something wrong here. Let me figure this out. Make sure I don't have my tops and bottoms mixed up. Okay, so I should have 7 over x, 6 over 5, 9 over y. Okay, so if I've got 6 over 5, 7 times 5 is 35 equals 6x. X equals 35 over 6. Yes. And then for y, I'm going to do 6 over 5 equals 9 over y. 9 times 5 is 45 equals 6y. Y equals 45 over 6. Oh, I think they just reduced that. So if we divide by 3, we would get 15 over 2. There we go. So 35 over 6 and 15 over 2. If you didn't reduce, that's okay. Alright, that's it for this lesson. Thanks for watching.